So this is a quick attempt to explain what pointers are. So if in a program I were to do something like x equals 42 and we'll print x, it prints 42. 42 is stored somewhere in memory, so pretend that this box here is the RAM and every location in RAM has an address, and let's just say the 42 is stored there for sake of argument. And say I say name equals Sean, print the name. Somewhere in the RAM, doesn't have to be sequential, is going to contain Sean. Now, what I could do is, for example, have another function, and let's just say, I'm just going to call it print, and it's going to print an integer. It doesn't have to be named x, I'll just call it n, and have it print the integer. So let's get rid of this, and now we'll just print x, and you'll see it prints 42. What happens now is when I call print with this x, and it calls this function, this n is also 42, but it's not the same 42. There's another location somewhere else in memory, that has a 42, so there's a copy. And that is significant for a couple of reasons. One is memory allocation, so my program is now using up more memory than it needs to. Another is, let's do this. This is printed last. X, so I'll print x. And you can see it prints 42 again. So let me come down in here and say n plus equals 8, make it an even 50. So you'll see when it printed out, it printed 50, but it printed 42 up here because this value is not the same as this value. It's a copy. So if I were to change that to be a pointer, so this function now takes a pointer to an int. So I will pass the address of the int. Then, let's see. Oh, there's the address. Okay, so I made a few changes here. So I set x to 42, I sent the address of x. So say in this case it's 1. It comes down here. Now, n at this point, being the pointer to an int, is actually the address in RAM. Like right here it's 1 through 20, but in real life they're much higher numbers. So the address of n is so you see in my memory, the address where it's actually stored is here. So instead of passing the number 42 to this function, it passes this value, and by using the asterisk to dereference that number, because n is a number, it's a value. A pointer is all a pointer is a number that points to an address somewhere in memory. And by using the asterisk, you can say, I want what that represents. So if, let's say this is position 1, and n was here, and its value was 1. That means this function passes 18 to here, and if I want the value of 18, I go down to 18, I find out what that number is, I go to that place in RAM, and that's the value that I want. So that's what a pointer is, and that's how it works. And the two main reasons are, one, memory allocation, and then also because otherwise you're dealing with a copy. And so if I were to have something, like say I wanted to update a user's password and I passed a user to a function, if that function changed the password on a copy, the original wouldn't have its password changed, and nothing would be done. So that's pretty much it.